In a novel I wrote way back in 2017, Echoes of Olympus Mons, I described gigantic lava tubes that were perfect for organisms like us to have created entire cities inside. While I won't spoil the climactic events of the book, I will say that I'm quite surprised when science news comes out with observations that are extremely similar to the things I wrote several years ago. It turns out, without even knowing it, that scientists and researchers in Hawaii were conducting an experiment that might see future Martian settlements utilize lava tubes to keep astronauts safe, just like those found on the islands. We're going to take a look at what this could mean for life on Mars in the nearish future. But first, be sure to hit that like button, comment your thoughts on exploring dead lava tubes on an alien world with nothing but a spacesuit to protect you, smash that subscribe button, check out the Patreon, and ring that bell to never miss a video. I'm Eric Malachite, author of Echoes of Olympus Mons, but you knew that. And this is ScienceGet. In our extremely depressing video series on why Mars is a bad idea for colonization, right now at least, we highlighted some of the reasons why colonizing the red planet's surface might be challenging. The first settlers there will have to protect themselves from life-threatening phenomena like harmful radiation, deadly perchlorates, crippling depression, and low Martian gravity. And it turns out that these researchers and scientists on Mauna Loa are part of the International Moon Base Alliance, which sounds like an awesome supervillain group. I mean, they already have a volcano for a base, so yeah. Which is an association that is working toward the goal of putting a moon base on, well, you know, the moon. The International Moon Base Alliance, or IMBA, is another arm of Hawaii Space Exploration Analog and Simulation, or HI-SEAS. HI-SEAS creates analog missions for astronaut scientists designed to mimic the conditions found on the red planet. During HI-SEAS missions, a team of up to 6 crew members live inside one of these lava dome habitats for weeks or even multiple months on end. Let's find out what kind of challenges they've faced thus far. Newsflash, spacesuits are bulky, really bulky. Well, Elon Musk has been hard at work developing sleeker, less cumbersome suits, and NASA will more than likely give Elon all their cash for the final design. It's unclear as to whether or not the suits worn by astronauts Doug Hurley and Bob Behnken would work well in an environment like Mars. They certainly look cool though. These suits, however, are still experimental. Doug and Bob were actually the first humans to ever wear them, and the ones currently in use at the ISS are still pretty bulky. The lack of mobility is especially challenging for astronauts hoping to conduct sensitive scientific experiments, as one mistake could see their precious samples being contaminated. Have you ever tried to do fine motor tasks with thick gloves on? There's a reason why Neil Armstrong's spacesuit had to have a special camera built into it. As mentioned in our first video on moon myths and misconceptions, there would have been no way for him to lug around a heavy camera back in 1969 along with all the other gear he was carrying. The astronaut scientists participating in HI-SEAS's Mars habitat simulation face similar challenges, without the threat of dying if one little mistake is made, of course. Each of the scientists is given a specific role, like commander, operations officer, crew engineer, and science communicator. I wonder if they have a botanist specialization. But tasks are also shared between the team members as well. Michaela Musilova offered a glimpse of such a mission during a presentation on March 19th at the 52nd Annual Lunar Planetary Science Conference, LPSC, which was held virtually thanks to the pandemic sinking its dirty fingers into everything. Musilova had this to say about the missions. "We usually have multiple crew members that can do similar tasks, and if someone is hurt or tired, there's always someone that can replace them. I've run almost 30 analog missions there since 2018. We have to prepare for everything in as much detail as you can, because in space so many things can go wrong. Even the smallest things can affect the mission and cost someone their life." On both the Moon and Mars, scientists are especially interested in lava tubes, as they may be the most likely place to find extraterrestrial life. In the last couple of years, we found plenty of reason to think this, such as new bacteria and microorganisms being discovered around the ISS, and the seemingly never-ending list of extremophiles that continue to test what we think is the upper limit of microbial life. It has no limits. Interestingly enough, HI-SEAS is partnered with NASA in the study of Mauna Loa's extremophiles. The lava tubes of Mauna Loa are home to various extremophiles, and HI-SEAS works with NASA to study them. These extremophiles leave deposits throughout the lava tubes they inhabit, and sampling and studying these organisms as well as their byproducts may be the key in training future Mars astronauts how to correctly handle such organisms if they're discovered on a planet like Mars. To quote The Martian by Andy Weir, "Space is dangerous. Anything and everything can go wrong. Biological samples can easily be contaminated. If the astronaut trips and falls, precious tubes containing specimens could be lost." And Musilova says that it's also the job of HI-SEAS to measure the toll that all of this work takes on the human body. Musilova continued by saying, even without an analog spacesuit, it can take hours to collect certain samples when you're trying to do it carefully. Now you add a spacesuit. It restricts your movement and vision. You can only bend or turn your head so much because of the helmet. You can only bend and kneel on the ground so much because of the way that the life support system is attached to your helmet from your backpack. So you're very limited in what you can do. The more we can prepare on Earth for what we're planning on doing in space, the better. But as it turns out, the lava tubes here on Earth are nothing compared to the ones that our astronauts would have to live in. It's been suggested that the reason why the volcanoes on Mars, including the granddaddy of all shield volcanoes, Olympus Mons, grew so large is because of its low gravity. And the same may be true of the moon's lava tubes as well. We're also not certain how volcanic activity happened or happens on Mars or the moon, as those processes could be very different from here on Earth. For example, it's thought that Mars does not have plate tectonics like we do here on Earth. Here, hot spots remain stationary, but the crust is always moving over them. In the Hawaiian Islands, for example, the Pacific plate moved northwesterly during their formation, while the hot spot produced the original volcanoes that formed the islands. On Mars, however, the crust remains stationary, so the lava just continues to pile up, making volcanoes that range 10 to 100 times larger than anything we have here on Earth. While we still don't know that much about Mars's interior, this is likely the reason why these lava tubes are so massive. And if it turns out to be the case on Mars, then perhaps the moon was similar in its ancient past. The last time the moon had active volcanoes was during the age of the dinosaurs, so we won't really know until we can explore more than 5% of the surface. But some of you might be asking, but Eric, how do we even know there are lava tubes on the moon and Mars? And I'm glad that you might or might not have asked that question. We've observed evidence of lava tubes by the presence of so-called skylights, which is when a lava tube's roof caves in. There are tons of orbiter images from the moon and Mars of these crater-like formations, some of them as deep as 100 meters or 330 feet for all of us heathens in the US. As a bit of speculation, thank you, computer. It makes me wonder how deep some of these tubes might go, and what is waiting for us deep within Olympus Mons. Some of these formations are as large as 40 kilometers wide, and that's more than large enough to contain the first city on Mars, isn't it? And what's more is that these tubes will shelter our astronauts from harmful cosmic rays and hopefully provide some protection from dust storms and Mars's many other dangers. If you dug this content, be sure to hit that like button and tell me the first thing you'd do once you got to Mars. Answers in the comments. And be sure to smash that subscribe button, ring that bell to never miss a video, and check out the Patreon, where you can get early episodes of the show, short science fiction, dark fantasy, and horror stories, your name in the credits, and more. I'm Eric Malachite, and I'll see you next time.